Okay, we're going to cover classification of matter. States of matter recap. Why the different states? So we have solid, liquid, and gas. But what causes them to be in those different states that we saw on Friday? So it's all about energy. Remember my crazy dance? Slow, medium, fast. And I didn't get to dance for all classes, but you will see it eventually. Solids, again, they are very, very tight. There's no collisions, but they are indeed slowly vibrating. If I could punch an object right now, I would, but everything in my room is very fragile. Liquid molecules are more free. You guys get to see that right there. They have some collisions. And last but not least, y'all, gas molecules move all over the place. And then they have many collisions because they move so fast. Again, kinetic energy, y'all, solid to liquid to gas, going from low kinetic energy in solid all the way to high kinetic energy in gas. So matter has two overall categories. Remember, classification is similar to defining that relationship. You guys can't assume one definition or another. You guys have to define it in order to classify it. So the first category would be pure substances. The second category would be mixtures. Let's go over pure substances first. Pure substances, y'all, they consist of only one type of matter. So we look at the substances in the pictures is only composed of one thing. Next, they can only be separated by chemical means. So make sure, y'all, that you guys underline that word, chemical. They can only be separated by chemical means. And the example is electrolysis. I'll repeat, electrolysis. Types of pure substances would be, first one, element. An element is composed of identical atoms. So we see the picture on your right, atoms of an element, molecules of an element. Remember, same color, y'all. They could be atoms or they could be molecules. So examples would be copper wire, that would be an element, copper, from the periodic table, and aluminum foil. That foil is made up of only aluminum atoms. So the second type is pure substances, a compound. Compound is composed of two or more elements in a fixed ratio. Again, two or more different colors or shapes. So properties differ from those of individual elements. Okay? Properties differ from those of individual elements. For example, remember our table salt? We had sodium metal, which is an explosive metal when put in water, chlorine, a very toxic gas, but when put together, delicious high blood pressure causing substance. Pure substance composition, y'all. So, law of definite composition simply states that a given compound always contains the same fixed ratio of elements. Meaning, if I have two hydrogen to one oxygen atom, it will always be water. Okay? If there are two hydrogen atoms touching one oxygen atom, it will always be water. That's the law of definite composition. Law of multiple proportion states that elements can combine in different whole number ratios to form different compounds. So, if I were to add another oxygen to water, it would definitely change into something else. Specifically, hydrogen peroxide. Notice, y'all, two hydrogen atoms combined with two oxygen atoms. So all I did was I added one more oxygen, and that addition of that one oxygen caused that compound to change into hydrogen peroxide. Okay? So again, let's illustrate those concepts. So a compound has definite composition. It has one carbon atom to one oxygen atom. Definite composition. That's always going to be always going to be, always going to be a pure substance, y'all, if it has a definite composition. One carbon to one oxygen combination creates carbon monoxide. And then the law of multiple proportion states that if I add another oxygen to it, it will change into a different compound, like CO2, which we know to be carbon dioxide. Well, I want you guys to circle that word or write that word in your notes. Again, pure substance compound, y'all, has definite composition. One carbon atom to one oxygen atom creates carbon monoxide. For water, like in the last slide, two hydrogen atoms and one oxygen atom creates water. Definite composition. I can't stress that enough. Definite composition for pure substances. To separate a compound, y'all, we need a chemical means, meaning electrolysis. Electrolysis is a chemical means to separate a compound into its parts that requires energy. It brings about a chemical change. So again, let's take a look at this illustration. We add 9-volt battery, and then notice, y'all, the water molecules separated into oxygen gas and hydrogen gas, as seen in this equation to your left. So again, this is chemical separation, electrolysis, only used to separate compounds or pure substances, y'all. So we talked about pure substances as the first category. The second category, overall category, would be mixtures. Two or more compounds physically blended together and can be separated by physical means. Make sure you underline that word physical. Whoa, whoa, whoa. There are two types of mixtures. The first one is homogeneous mixture. It looks the same throughout. So how can I tell the difference between homogeneous and heterogeneous? So heterogeneous is defined as can see different parts. So notice, y'all, it's all about the appearance. Okay, so if I were to take a look, physically look at that picture above, right there, that is considered to be a homogeneous mixture because it is, or it physically looks the same throughout, no different parts. But if I were to take a look at this picture below, it looks like there are a lot of stuff in this jar. So again, that is considered to be heterogeneous mixture. Other types of mixtures that you might need to know, salt water, right? Salt water looks the same throughout, y'all. Even though it has table salt and water in it, it looks the same throughout. So it's considered to be a homogeneous mixture. Salt water is definitely different than water itself. Water itself looks like that homogeneous mixture, the same throughout, but it doesn't have table salt. And so water is just called a compound, a pure mixture. So make sure you guys get that difference down, y'all. Water by itself, only composed of one thing, compound. And over here, salt water looks the same throughout, is homogeneous mixture. So the first physical separation technique would be filtration. So we use a funnel and filter paper to collect the solid and then the liquid runs through. So in filtration, solid substances are separated from liquids and solutions. Okay, so filtration, easily defined as separating solid from liquid. Solid from liquid. So again, equipment used, filter paper, funnel, and a beaker. I'll repeat that. Again, equipment used, funnel, filter paper, and a beaker. So we have the second physical separation technique. This is called distillation. So distillation separates two solutions from each other based on boiling point. So distillation uses the difference in boiling point to separate a homogeneous mixture into its different parts. Again, distillation separates based on boiling point of a homogeneous mixture. Chromatography. So, chromatography is a technique that separates substances based on the difference in solubility in a solvent. So, we have two stages of this chromatography, y'all. The mobile phase and the stationary phase. Stationary phase is simply that filter paper that you guys see. Mobile phase is the solvent moving this colored ink up the paper. As you guys can see, the purple ink is at the bottom, meaning that it is heavier. And then the blue ink is at the very top in the last picture, and that simply means that it is lighter. Okay, so again, separated based on the differences in the solubility of the solvent. So, matter can be categorized in pure substance or a mixture. Pure substances can be categorized as either compound or an element, mixture, homogeneous mixture, or heterogeneous mixture. Devise a way to classify matter into specific categories. So I want you guys to take this time now to pause and think about this process. Time for 2 minutes. So what do you look for to classify matter? Try singing the ABCs. A. Appearance. Does it look the same or different? B. Bonding. Can it be separated physically? Or does it require a chemical reaction? C. Composition. Definite or indefinite ratio of elements, molecules, and compounds. So let's take a look at each one. Appearance, y'all, only goes for mixtures. Remember looking at it, right? So once you identify whether it is a mixture, using the other ones, bonding and composition, you guys can see whether it is homogeneous mixture or heterogeneous mixture. Again, if it looks the same throughout, y'all, homogeneous mixture. If it looks different throughout, y'all, then it is heterogeneous mixture. Bonding. So physical separation is always going to be a mixture. And then chemical reaction would be a pure substance, most likely a compound because we can't break down an element. Last but not least, y'all, composition. Definite composition tells us pure substance. Okay, pure substance. Indefinite ratio means like the sand. If you guys were to pick up sand, it will have different atom counts of everything inside that beaker of sand. So that's indefinite ratio of elements, molecules, and compounds. So those would be a mixture. And sand specifically, y'all, you best believe sand does look different throughout. So again, a heterogeneous mixture. So let's look at a flow chart to help you guys classify matter. Given a sample, you guys should be able to categorize it as either a pure substance or a mixture. So the first question you have to ask yourself would be, is it uniform throughout? So does it look like it's all the same? Okay, that's all that word means. So if your answer is no, okay, then it is a heterogeneous mixture. But if your answer is yes, then it is a homogeneous mixture. Does it have a variable composition? So, is there more than one type of thing? So, if your answer, y'all, is yes, then we have solidified the answer as homogeneous mixture, okay? Then, if it is no, then it is considered to be a pure substance. Can it be separated into simpler substances? Or is there more than one type of element? So, if your answer, y'all, is no, then we have an element, and if your answer is yes, then it is considered to be a compound. So this is the key, y'all, we need to use in order to classify matter given a substance. So first thing you need to look for is whether it looks the same throughout. If it looks different, Then we have heterogeneous mixture. If it looks the same, then we know it's homogeneous, but not yet with mixture. Then we have to ask ourselves, does it have variable composition? Meaning more than one thing, right? So if the answer is yes, then it's a homogeneous mixture. If the answer is no, then pure substance. And last but not least, can it be broken down into simpler substances? Meaning more than one type of element, question mark? Answer is no, element. The answer is yes, compound. Okay, y'all. I want you guys to look over the lab videos posted on Canvas. Okay? So again, that lab will help you guys out with your exam. Your exam is still going to be on that Wednesday. So let's make sure you guys got this. Okay? Cool deal. I wish I was there with y'all, but I can't. So have a good one.